Okay, let's give you guys some more practice. So find the volume underneath this surface in this specified region. So press pause and have a go. Okay, so to do this, we need to understand the region in which we're integrating over. So so we need to translate this. So this is your inner integral. Because of dy, then it's going to be y equals something, and then the outer integral, it would be x equals something, and then if looking at this, if I were to give you this y squared plus x squared equals 1, then you know this is a circle of radius 1. If I take away x squared and then square root both sides, this will then give me the positive version and the negative version. So the positive version is this upper circle here, and the negative version is this lower semicircle here. So we are interested in the lower semicircle because there's a negative here. So that means we're interested in this part here. So it's saying, looking at this, moving in the y direction, moving parallel to the y axis, it's saying, moving parallel to the y axis, it's saying move from the bottom semicircle to y equals 0. So it's saying move from the bottom of this semicircle to y equals 0, bottom of the circle 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 to y equals 0. But it's saying scan in the x direction, scan from -1 to 0. Well, -1 is here and 0 is here. So scan from -1 to 0. So you're scanning along like this, and then you stop at x equals 0. So really we're interested in this region here. So you're scanning like this, you're interested in this region here. So this whole thing here, hang on, so this whole thing here really boils down to us integrating over this region. So so to translate it to polar form, we would replace this with this thing here. Looking at this, it's going to be r first, so it's going to be r equals something, and then looking at the outer integral, it's going to be theta equals something, and in polar form, you're moving along like this. In polar form, you're moving along like this. So so in terms of r, it would be r equals 0 to the radius, r equals 0 to the radius, r equals 0 to the radius of 1, 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 because our circle has a radius of 1. And then in terms of the angle, you're scanning the angle from here. Hang on, you're scanning the angle like this from pi equals from theta equals pi, and stop at 270 degrees, which is stop at 3 pi over 2. So so translating this whole thing into polar form would take us to here, because if you look at this, r squared is x squared plus y squared, but then this is a square root, so so that would mean this. So you would put r into that thing there. That will then give you this r here. So translating this whole thing into polar form would take you to here. This is just a constant, so you can take it out, giving you and this r gets multiplied to the top, giving you this. So we are currently at this stage here. Remember, we've taken the 2 out here. Okay, so right at the end there's going to be this 2 hanging around. Anyway, we've got a 2 out here, so it boils down to us trying to evaluate this thing here. So it boils down to us trying to integrate this thing here with respect to r. So so let's turn this into a single calculus. So in single calculus, if I were to ask you to integrate this, you would use substitution. So let u equals this thing here. So du equals dx. So we would put u into here. That would then give us this. And what is x? X is u minus 1. So x is u minus 1. So this thing here will become this. Dx is really du, because here du equals dx. Well, we've done this before. I'm expecting you to be able to integrate this. And then break this up to, this is the number 1, and then 1 over u. And then integrate it. When you integrate 1 with respect to u, it's just u, and this is natural log absolute value of u, and then substitute u back in there. It will then give you this thing here. So hang on, going back to here, it boils down to us trying to integrate this. When you integrate this thing here, it will give you this thing here, which is what we've done over here. So you can see that we can put this into here. Okay, but it's not I made a mistake here. It's not x, it should be r. Okay, so remember, I turned this into to x just to illustrate it to you, but I forgot to turn this into an r, So bear with me, erase, bear with me, r, and then you've got erase, hang on, r, and then that should be correct. Okay, so when you integrate this whole thing here, it will then give you this thing here. So now remember, we're integrating from r equals 0 to 1, r equals 0 to 1. So we would put 1 into here. That would then give us hang on. That would then yeah, put 1 into here. Put 1 into here. So that would give us, hang on, so this thing here would be 1, and then plus, when you put 1 into here, that would be 1, and then you take away, put 1 into here, so that would be natural log of 1 plus 1 is 2. We don't need the absolute, because we know that the number 2 is positive. So that would then give us 2 here, natural log of 2 here, and then you take away, and then you put 0 into here, so that would then be this thing here. Put 0 into here, which would then be, remember, it's take away a negative, so that would be a positive natural log of 1. So well, this whole thing here, if you think about it, pause the video if you want to, it becomes this whole thing here. Okay, and then 2 take away 1 is 1, and then this natural log of 1 is just 0, so it gives us this thing here. So now integrate it with respect to theta, meaning that this is a constant and this is a constant. So when you integrate it, it will give you theta. Integrate this, it would be theta natural log of 2, and we're integrating from pi to 3 pi over 2, from pi to 3 pi over 2. So put this into here, and then you take away, put this into here, which will give you this, and then put this into here, that will then give you this. So now multiply everything by 2, that will then give you this, and then tidy it up. The whole volume is given by this thing here. Okay.